This one's all going to be on distributive property. So remember our learning target. This is what we're really wanting to focus on. We want to really understand commutative associative and distributive properties. So this one is all going to be on distributive. And when you hear the word distributive, you think of distribute, hand out, pass out. Like if I'm a truck driver, I have this one truck with many things in it. I'm going to take some of the stuff over here, some of the stuff over here, some of the stuff. It's going to be distributed among different things. So in math, you might have a problem like 3 and then parentheses 4 plus 2. Now, when you have parentheses and you have a number next to it, which kind of means, it doesn't kind of mean, it means multiplication. So in order of operations, you might do this first, 6, and then 3 times 6, and you're going to get 18. Okay? Now, because this is next to it, something with parentheses, you can distribute this to each member, each term of the parentheses. So I have a term here and I have a term here. So let me erase what I did here, and I'm going to show you how we distribute this. So I'm going to do 3 times this, and then I'm going to do 3 times this. So I go 3 times 4, and then add 3 times 2. Okay? Now this is the same way to say it, it's just it's distributed. I distributed this 3 to this and to this. So 3 times 4 is 12 plus 6, and it equals 18, which is exactly the same as what we got if I did this parentheses first and then multiplied it by 3. But there's some times where you're not going to be able to do anything in here, and you have to distribute it. When there's a variable, that's when it's going to come into play. So let's look at something with a variable. So say I have the variable f. So I have 4 times 2f plus 3. Okay? Now, order of operations tell me to do this parentheses first, but I can't. And the reason why I can't is because with adding and subtracting, you need to have like terms. And what that means, this is 2f. The term equals 2f, and the other term equals 3. So I have these two terms, okay? And they're going to be added together, but two terms, and when I'm adding them, they have to be like. If this would have an f, then they would be like terms. They'd both be a number with the same variable, and this would be 5f, okay? Or if this didn't have an f, if it was just 2, then they're just two numbers, and they're like terms. They're both a number. So 2 plus 3 is 5. But because this has an f, you're not going to get 5f, because the way you think of it is this is f plus f, and this is 1 plus 1 plus 1. Okay? So I have my 2 f's and I have my 3 1's. Nothing is alike. Okay? These 2 f's are alike. So when I have 2 f's, I can multiply that together and have 2f. Okay? 2f. I have 3 1's. So 3 times 1 is 3. These are like terms. These are like terms. This one and this one are not like terms. They're not the same. They mean different things. So, I come over here. Now, I can distribute it, okay, with multiplication. So, what I can do is I can go here, multiply that, and I can go here, multiply that. And both of these are going to be multiplied by the 4. So let me write that out for you. I'm going to have 4 times 2f plus 4 times 3. Okay? So I've distributed this 4 here. Now I can simplify it a little bit. Here's the tricky thing. So 4 times 2f, I can always do that because of the multiplication property that says this is also multiplication. So it doesn't matter what order, what number, what anything. I can put these together and I'm gonna be okay. So 4 times 2 is 8 times f is 8f. I can put that together, okay? Because it's all multiplication. It's like I'm multiplying 3 things. I'm multiplying 4, 2, and f, and I can put it all together. On this one, it's 4 times 3. That one's 12. Those are like terms, and it doesn't even matter with multiplication. So we have that 8f plus 12. I cannot do that. I cannot do that. And let me show you why I can do that and I can't simplify that. So if I try and simplify this or put it together, you'd say I have 20f. Okay? Now, if f is 2, say f equals 2. So if f equals 2, I'm going to put my 2 right here and put my 2 right here. Okay? 2 times 20 equals 40. Now, 8 times 2 is 16. 16 plus 12 is 38. I didn't get the same number. So I can't do this. It does not work. So with addition, subtraction, I cannot add those together because you have a multiplication and an addition. It has to all be multiplication. So let's look at this one. I can put this to equal this. And the reason why I can do this, let's see if it's going to get me the same thing. Let's say f is 2 again. So here it's 4 times 2 times 2. This one is 8 times 2. Let's see if I get the same thing. 4 times 2 is 8. 8 times 2, that's 16. 8 times 2 is 16. Because it's all multiplication. It's the same thing. So that's why you can multiply unlike terms. So you have this 4 and you have this 2f. Okay, they're not like. You have f's and you have 4's. But because they're all multiplication, 4 times 2 times f, you can multiply it out together because commutative property of multiplication. It's always going to get you the same answer. So you can put it all together, you get 8f. Okay, that's kind of a tricky thing to understand, and but it's really important that you can multiply those together. As long as it's all multiplication with a variable, you can put them together. Let's do another one here. Let's do one with like terms, and then I'll do one without like terms. So like if I have 5 times 3t minus 2t, okay? And I could do this order of operations. These are like terms, so I could actually do this. 3t minus 2t. It's the same as, okay, there are my 3t minus that t and minus that t. So I'm taking away 2 t's, so this t takes away this t, that t takes away that t, I'm left with 1 t. Okay, so I could do 1t times 5, and that's going to be 5t. Okay, all right. So I can put these together because they're like terms. Now I could also do this in the distributive property. So I'm going to take this, go this way, and then, well, let's do that first. So 5 times 3t, and then I'm going to subtract because it's subtraction, and then I go over here and I have to distribute it to this one. Okay, 5 times 2t. Now I can simplify this. It's multiplication, so it's 5 times 3 times t, all multiplication, 15t minus 5 times 2 is 10, times t is t. 10t is going to get me a total of 5t, which is what I had before. Okay? Now, let's do one last problem. And I'm going to make that a y instead of a t. Now, I could still distribute it. Okay? Go over here. 5 times 3t, still subtraction, and then 5 times 2y. Now I can put these together. 5 times 3 times 3, 5 times 3 times t is 15t minus 5 times 2 times y is 10y. Now, these are in unlike terms, so my answer is that. Okay? Distributive property, it's pretty foundational to algebra. Really important to know how to distribute and what it looks like and what it means and why you can do it. So for your homework, I'd like you to, on a piece of paper, any piece of paper, put on top distributive property and write 2 problems. 2 problems, one with no variable, okay? So it's going to be like 5 times 3 minus 2. So no variables in them. And then show me how you distribute it, okay? So you show me this part and then how you distribute it. You can solve it or simplify it if you want, but I want to see how that you know how to take this and distribute it so it looks distributed out, okay? So do one with no variable, and then do one with a variable, okay? So I can see that you're understanding how the variable plays into, and just have one number with a variable, like a problem similar to this, okay? So where one of the number has the variable, and it can be addition or it can be subtraction, either one. But do this and then show me you know how to distribute this out. Okay? So 2 problems, one with no variables and one with variables. Write the problem, distribute it out for me, and then you can simplify it so I can see that you understand this whole distributive property idea. Okay? If you have any questions, come see me. We'll talk it through and we'll figure it out together.